Lesson 10.4 on volume problems. In order to solve volume problems, we need to be able to make good use of equations. For example, in this triangular prism here, we're given the height of the triangular prism, and we're also given one of the two dimensions of the base of the triangular prism, and we're given the volume. But we need to find the length of the triangular base. Well, in order to solve this problem, we need to remember our formula. Now, to find the volume of a triangular prism, it's just the area of the base times the height. And to find the area of the base, it's 1/2 times the length of the base times the height. Standard area formula for a triangle. But since I actually don't know the difference between the height of the prism and the height of the triangular base, I need to make a distinction between those two variables. So I use subscripts. We'll call the height of the actual triangular prism the h sub 1, and the height of the triangular base h sub 2. With that in mind, let's actually construct an equation based on these formulas and substitute in the values that we know. We know that the volume of this prism is V equals B times H1, and the area of the base is 1/2 times B times H2. Putting in that formula, we get this volume formula here. And we now know the area, we know the volume of the prism, that's 1440. We know the actual height of the prism, that's 24. And we know the height of the triangular base, that's 8. We don't know the area of the length of the base. So we need to solve this equation now for B. To solve it, well, let's go and multiply 8 times 24. We get 192. Then we need to undo everything that's being done to the variable b. Although before we do, we can take 1/2 of 192. That gets us 96. And then solve for b by dividing both sides by 96. And we get b equals 15. So as long as you're familiar with your formulas, you can use them to set up an equation to solve for the unknown variable. Now, some of the problems we're actually going to be doing in this lesson are going to become much more tricky. But if you read through the problem and also make use of diagrams, you should be able to reason your way through the problem. For example, here, let's say that we're given an 8.5 by 11 inch sheet of paper, and we're asked to construct a triangular prism from that sheet of paper by folding it into thirds. And we want the height to be actually 8.5 inches. What volume of space is enclosed inside these paper walls? Well, let's try this out. In order to get a good handle on this problem, let's draw a diagram. Here's our sheet of paper, 8.5 inches tall, 11 inches wide, and we want to divide it into 3 sections. We want to fold it into 3 pieces to make a perfect triangular prism. So let's divide it up into 3 sections. Well, if we take that 11-inch length and divide it into 3 pieces, each section there, each dimension is 3.67 inches long, rounded to the nearest hundredths place. Now we can use that information when we draw our actual prism. Our triangular prism still has a height of 8.5 inches and has a base of 3.67 inches in its triangular base. But in order to find the volume of a prism, we need to know the area of its base. While we know the length of the triangular base, we don't necessarily know its height yet. But we do know that any length in that equilateral base is 3.67 inches. So let's make good use of what we know about triangles. If we were to draw an altitude there through the triangle and divide it perfectly in half, we know that the triangle is an equilateral triangle. So any angle is 60 degrees. But since that top angle there is 30 degrees, that's divided the triangle there, that angle there in half, and we have a 30, 60, 90 triangle. Making use of our 30, 60, 90 triangle ratios, the length of 1/2 of that base there is 1.83 inches. And then to get the length of the altitude, we multiply the length of the shorter leg by the square root of 3, getting us approximately 3.17 inches. Making use of these numbers, we can now find the area of the triangular base. The length of that base is 3.67 inches. The height The altitude there is 3.17 inches. Multiply that by 1/2. Altogether, the area of the triangular base is 5.82 square inches. Continuing this problem, now that we know the area of the base, we can then find the volume of the prism by multiplying the area of the base times the height of the prism. So the area of the base is 5.82 square inches. The height is 8.5 inches. Then we just take the area of the base times the height, 5.82 times 8.5, and we get for a final answer 49.47 cubic inches. Thus concludes today's lesson.